Hey folks, get ready to hack, slash, and slam on the gas with this month's free marketplace content. Put your pedal to the metal with an advanced vehicle system, embrace the elements with mesh based Niagara effects, seed your next project using medieval components, excel in the office with high quality assets, and power up your characters in a turn based JRPG template. Now, with the help of the permanently free physical layout tool, you can take your level design to the next, level. Claim all these free goodies on the marketplace today. Have you downloaded the new MetaHuman sample yet? We released 2 new tutorials to help you get the best performance out of them. Explore the scalability settings, including LODs, hair options, and toggling ray tracing, and then find out how you can use Control Rig to animate the MetaHumans to express emotion and your creativity. Watch the new videos on the Unreal Engine YouTube channel. And if you're eager for more information on the rise of real-time digital humans, the next episode of The Pulse will feature digital humans researcher and expert Dr. Mike Seymour, joined by talent from Sony Pictures Imageworks, Skydance Media, Brood, and 3 Lateral to discuss the recent exciting and innovative advancements in digital humans and their impact on the future of games, films, and beyond. The event takes place on March 17th. Head to unrealengine.com/thepulse to register now. We've teamed up with ArtStation to showcase incredible artwork created in Unreal Engine, Twinmotion, and with Quixel Megascans during Unreal Days. Hop over to ArtStation to check out the featured Unreal Engine channel and submit your own work to be highlighted. Ever dreamed of building your own home? A new real-time app created by Zuru Tech enables anyone to design a building and order the constituent parts for assembly on site. Head to the Unreal Engine feed to find out how this innovative idea could change the construction industry. In our ongoing journey to provide you with better resources, we've crafted a survey for the Unreal Engine documentation. If you accept this quest to help us shape the future, share your feedback and suggestions at the survey linked below or at docs.unrealengine.com. Now for our top weekly karma earners, many thanks to Everynone, Clockwork Ocean, Lizard89, Mama Marcis, Shepherd's Hook, T. Sumisaki, Fatal Break, Fabio M. Silva, FridgeFace16, and Firefly74. Popping over to our spotlights, we're celebrating this beautiful cinematic called The Lost Path, created by a handful of the folks at Team Code. Labeled as the first in a series, there's a lot to look forward to in their upcoming projects. Give them some love on ArtStation and then head to their site, badcodeqode.com. This lovely mini trailer was created by MR3D Dev using the Quixel medieval map with other assets from the marketplace. They've also hinted at future videos following Coming Home, so make sure to keep an eye on their YouTube channel for more content. And lastly, join the young Una on an adventure to complete her first task to become a full druid. Travel through thick forests and swamps, face the creatures inhabiting them, reach the Cloud Kingdom, and fight against the evil Mega in this beautiful 2.5D platformer. Una the Druid's Path is now on Steam. Thanks for watching this week's news and community spotlight.
Hi everyone, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Victor Broden, and with me today, I have Sebastian Loze, Industry Manager for Simulations, as well as Alban Bergeret, Solutions Architect for Simulation and Training. Welcome to the show. Today, we're going to talk a little bit about building simulation applications with Unreal Engine, and I will hand it over to you, Sebastian.
Thank you very much. Hey, everyone. We're super happy to be here with you today. Thank you for joining us, and thanks, Victor, for setting this up. We're really happy to be inside Unreal today. When you start the conversation like this, it's super important to define what we're talking about, and we all come from different horizons here when we gather in these sessions. And as we all come here online from different backgrounds, experience, and skill set, some of you might already be very clear and precise and get a very precise picture on what we call simulation in this context. But it's good to make sure that for the duration of this session, we're sharing a common lingo. So what really is simulation? That's what we're going to go through on this little deck that we have there that we can bring to the screen for you guys. So really, when it comes to simulation, and as you probably detected, English is not my first language. So as you probably detected, that's very important for me to, in some cases, go back to the dictionary, right? And let's do that together. Let's have a look at the definition of simulation from the Oxford Languages. So as you can see, the scope of application for the word simulation itself is very, very large, right? So we will be focusing today in this session. The part we will be focusing on today is this one, right? The production of a computer model of something to study, and we can extend it. These computer models are used to study, to train, or to analyze. The goal can be to either augment your skill set or preparedness to complex and unexpected events, or to train the robots, taking care of our transportation, our protection, or to evaluate new vehicles or automatic systems we are creating before they even exist. That's what we call simulation in the context of our conversation today. And if we take a step back, if we actually take a step back, I'm sure that if we're all in that call together, we all agree that we're living through a very exciting period of technological changes. In the past 5 years alone, we've seen a huge advance in cloud computing, in connectivity, artificial intelligence, and automation, as well as interactive and immersive technology. Across all aspects of businesses and society, we're seeing exciting shifts emerging as these technology continue to evolve, and in some cases revolutionize how we work, how we play, how we interact, but also how we train and how we learn. And the door have been opened to richer and more immersive experiences and content, from the game we play to the movie we watch, as well as the way we collaborate in the workplace and we train and set up or training and analysis of the world around us. And it's not magic, right? It's linked to some very tangible points, very tangible elements that we're going to discuss today. There are some specific elements specifically linked to your pipelines, right? How we create things. I mean, we've all been developing virtual applications for a long time. And in this context, it is remarkable to see the evolution between the traditional pipelines that we dealt with and we're still dealing with in many cases, and the real-time pipelines that allows for instant and almost instantaneous ways of creating or rendering your content in your scenes when you're creating new environments. And these new environments are dynamic. Like any video game, the simulation world is using exactly the same paradigm of non-linear content that can be evolving over time and that can be deformed by the decisions that the end users are taking. And the beauty of it is that this paradigm is not only touching training and simulation, right? It's not only about simulation. I know, Victor, when we prepped, reminded that to me. It's not all about you, Seb. It's about everything we touch, right? And all these universes that you see here, right? From architecture to advertising, the benefit from real time is everywhere. But today we'll dive in some examples and some specific use cases related to simulation. Before I'll dive in, I'll introduce this short 30-second video to reflect on some of the simulation use cases that creators worked on in 2020. So short video for us, and we'll discuss that just after. So it's a small vignette, right? As you can see from this little video, you know, simulation is everywhere, right? In autonomous vehicles, driving simulation, in aerospace, as well as healthcare, defense. It's a very large domain that is touching different places where it's either too hard, too expensive, or too dangerous to try things in real life, right? Don't try it at home. It's really the paradigm of simulation. If you can't do it in real life, you need to find a way to experience it prior of doing that to fail safely. And the problem with that, the challenge that everybody's facing is the digitalization of your world, and how do you bring your real world to the simulation environment. Within the audience today, we have tons of creators, inventors, or people creating universes that are far from real life. We also have people who want to replicate real life, and it's interesting to see that with one engine you'll be able to do both by using different techniques and different capabilities. And we'll dive on the simulation ones today. From the, as I said before, definitions are important. This one's coming from Wikipedia. That's another source that you can use. And here, it's a definition of a game engine, right? The important part here is that in the context of building a simulation application, many times people get confused and see only the shiny pixels and the beautiful images that you produce with a platform like Unreal, while at the core of it, it is a development platform that you can build upon and create any type of interactivity. And the values you will find in a simulation applications very often are linked to the values that you want in a video game as well. If you look at that table here, the only point that is different is your goal. In one case, people will enter an experience and will live a fantastic experience and be entertained by it. They will live something that they couldn't live in real life, and they will be, feeling all these emotions, connecting them with the characters or the scenario or the situation that they're playing. In the other case, and they'll leave the room with this memory of this entertainment and feeling that they went through. In the other case, in the case of simulation, what we want to achieve is we want the interactors with the experience to be augmenting their knowledge about something. They either will learn a skill set, or they will understand better the outcome of a specific paradigm that they will be testing to analyze that, right? So they are trained to learn and to learn new skill set, or they use simulation to augment their comprehension of the real world. So as you can see here, with all the environments that we are creating in the context of Unreal, the one that is the closest to a video game development is developing a simulation application, something that is not linear, that the operators or the gamers will interact with and will generate a different outcome depending on how you play it. And historically, from firefighters to different interactors in different fields, it was really close to third-person type gaming applications when we saw the first use of Unreal in the simulation domain. And it didn't start with us. It's really started by the community figuring out that, hey, instead of using XYZ solutions, I could actually build it myself with a game engine and have fantastic results out of that. Fast forward to today, the type of use cases evolved like crazily. It's not only a third-person type application that you're seeing, but it's any type of application that replicates exactly what you would do in any type of simulators, either to train people to do new things, to pilot complex vehicles to control, or to interact with complex elements of the human anatomy as you're training a surgeon on a specific procedure for orthopedic surgery, as you see on the top right corner here on that slide, or preparing for complex operations, as you see here with the brain pictures used by neurosurgeons in the Tokyo University when they're doing their research on how to reduce a clot on a brain prior to the brain operation. All these type of complex procedures can either be rehearsed, analyzed, or taught to the end users. So, to summarize, simulation is a very large field, right? It goes from space exploration to healthcare, passing by civil aviation and earth-moving equipment training. And because of all that, we have to make sure that we have a very complete platform solution with Unreal Engine to ensure that no matter what is your use case, you find the right tools within Unreal. And when we look at the workflow that anybody would be using when they're building a simulation application, it always goes through three main phases. I mean, there are more than that. But if we take a very, very high level point of view on any simulation application, you always have three main phases. You will create your content, the environment you deal with, and the objects that you interact with. You will develop your scenario, and you will create some specific interactions and some deployment capabilities for your solution so that it can go to your end users. So from that standpoint, again, it is another similarity to video games, right? You have your content, your storyline, and your gameplay. The same type of mechanism exists there. And while some of you are more familiar with simulation today than gaming and vice versa, you can see how these two universes are feeding each other, and in terms of innovation are represented by the same needs to evolve. And now we'll dive into a more detailed slide, and bear with me. I hope that you don't have a too tiny screen, otherwise you won't be able to read that, but we'll help you by zooming in. So yeah, that's small. That's very, very small. But there are color on that slide. I hope you can see it. You can see these different phases represented again. Environment, creating your environment and your models. Defining the experience definition and the execution. Deploying your application, and making sure that you have a post-experience result analysis. Let's dive in, and we'll be nice and we'll zoom in on some of these boxes. So first off, the environment and model creation. While there are a lot of tools within Unreal Engine that allows you to create and inject a lot of objects into your applications, in the simulation domain, some specific tools and specific formats are important to be supported. And we want to make sure that we build an ecosystem around Unreal. So we associated ourselves with different players of the simulation industry to ensure that their formats are supported properly into Unreal, either through elements that we would develop or through elements that they would develop. And as you can see here, from the pipeline tools to the capabilities of streaming different terrain formats, we have a complete loop to ensure that no matter what is your favorite tool, no matter what is your favorite pipeline, there is a way in for you to jump in Unreal and not suffering while you're developing your application. And by the way, today we have Alban with us, and that will be part of his presentation at the end of our session today, where we will be presenting two examples of streaming services of geo-intelligence content, geographical content that can be now loaded directly and streamed directly into Unreal. We'll give the example of the Cesium 3D Tiles, so Cesium for Unreal plugin, And we will also have a demonstration of the Esri ArcGIS Maps SDK for Unreal Engine plugin. And we will show you how to inject all that great geographic content into your applications. It's super simple. You will see there's a couple of very, very well-defined steps. And it's not magical. It's all based on the great work that we did with our partners to make sure that this comes to you in an easy way. Now, when it comes to the experience definition and the execution, the creation of scenarios, the creation of initial conditions, there are specific objects and specific components within Unreal that you all know about, that you've seen demonstration of recently with the rising of 426, with these new capabilities for the different modules that we have for the sky atmosphere, the volumetric clouds, the water system as well. All these components can be directly leveraged, obviously, in the context of simulation. And in that specific context, there are some modules in the execution of your scenarios that are representing a very strong advantage in Unreal in the simulation context. For example, we can talk about chaos, right? And the ability to, through chaos physics, having a lot of new capabilities, including the full body IK that came in very recently into your applications. On top of that, because we understand that monolithic simulations are not trendy anymore, and that everybody is dealing with non-walled gardened environment where we can interact with different simulation systems to make sure that we bridge correctly with your existing simulation engines. The interoperability is a core element of what we need to maintain as part of Unreal, and that's why you have these new plugins created by Peach, by CoreDS, allowing to have all this interoperability set up so that your traditional communication protocols, such as DIS or HLA and soon DDS, are supported as part of your application in Unreal. And yes, for those of you who are not familiar with simulation context, welcome to this acronym fantastic universe, right? We have plenty of acronyms. Any question, feel free to use the or exchange chat capabilities to ask all your questions. We'll dive in during the Q&A session, and Victor is already aggregating all of your questions as we speak. Another element about the experience definition and the execution is the co-simulation capability. You probably, in the simulation domain, you probably already use some expert tools for your for specific physics element, or for specific sensors, or for specific behaviors of your objects in your scenes. And this co-simulation aspect is super important. There are some plugins already existing for many of the players. The nature and the structure of Unreal, and we'll talk about that a little bit further down in this session today, the nature of Unreal allows you to build your own module as much as you need, right? A good example of that is the example that we released today. There's been a story posted about Duality, and Duality, they're building the Falcon software. Their application is a machine learning and AI-oriented simulation engine based on Unreal Engine, which allows to leverage this co-simulation capability to have your machine learning interaction directly connected with your Unreal Engine experiment. The article that we posted today is really focusing on their experience and their development around Falcon and the dedication they had on that one, specifically around the Honeywell Aerospace drone surveying tool to analyze the status of the power grid electrical lines as well as the wind turbines that they are monitoring. In terms of deployment, there's also a lot to be said here, but you heard us many times at Epic talking about these elements, right? We want to make sure that no matter where and how you plan to deploy your application, your game, your simulation system, you're covered, right? We want to make sure that either if you're deploying on handheld devices or computers or through any type of HMD, we give you the flexibility to deploy your application the right way. And furthermore, in the context of simulation, many times, especially when you're dealing with complex civil aviation applications, for example, you will want to have a dome display around your trainee, and to ensure that this is something that you can do very easily, we have this ability with NDisplay to help you to blend and warp your images between different projectors in a very coherent way. And that's another key element that is leveraged by a lot of simulation builders. Last but not least, the post-experience result, which is extremely important. Many simulation developers had that challenge from aggregating systems that they didn't fully control. Let's say you're playing Lego bricks and you're aggregating a lot of applications together. If you don't have the access to the data set that is generated by your application system, you will not be able to export all the interactions, all the behaviors of your trainees or your analysts throughout the course of the experiment that they will be running, and you will be missing out all the value of this training. You won't be able to do an after-action review correctly. You won't be able to connect with your LMS correctly. So that's where this openness of the core of Unreal Engine is super important. So it's a lot of information, and I hope I hope you're staying. I hope you're still here. I know with Victor we have that subtle cue that he would wave at me if everybody's leaving suddenly. Are they still here, Victor?
They're still here, as far as I can tell.
Good, thank you. So to summarize, when you're developing a simulation application, it's basically some sort of a layer cake here. So you have your framework level where you have your development environment, your standard databases, your interoperability protocols, as well as your game engine. On top of that, you need to build your integration effort to connect with any other tools that you want to connect with. On top of that, you will build your specialty features implementation. And then based on all that, you will establish your curriculum definition or your experience definition. Now, what we want to make sure is that while we're bringing you a very solid platform for your framework level, we want to center the integration effort for you and make sure that most of the integration that you need are taken care of by our teams or with our partners in advance of you developing your applications. And that's why we're here. We're really here to hear back from you and understand what it is that you need to simplify your process when you're developing your applications. I talked a little bit about the pipeline. I won't dive into too much because that's really part of the core of our demo today. But in a nutshell, there are several elements that are important to notice, right? The first one is, as some of you know and are expert with, Datasmith and DataPrep are allowing you to inject into your simulation application virtually any type of 3D assets that you already have on file, right? These systems, these specific formats that you're already using, we don't want you to have to reinvent your files or adapt or adjust to a new pipeline. We want to make sure that you use your existing pipeline and you're able to not only load but also optimize this content when you're building your actual real-time applications. And once you set up your pipeline, and these pipelines can be set in 3 different ways, right? They can be set based on coding using C++, or using Python scripting, or using our visual programming interface, which is the blueprint concept that you see here. Once your pipeline is set, you can reuse that and make sure that you leverage that moving forward. When it comes to the geographic data set that you want to integrate into your application, there are already a ton of tools within Unreal with the landscape capabilities, the foliage tools, all the marketplace assets that already exist and allow you to already build games, and all this content that we call geotypical, right? Geotypical context, geotypical environments are environments that look like the real environment, but are not actually the real environment. So that's geotypical, right? And in some cases, you want to create geospecific environment. So geotypical looks like the real thing, but it's not the real thing, but looks like very much the real thing. Geospecific is actually the real thing. So I'll give you an example. If I fly over a terrain that is geotypical and that is supposed to represent Montreal, where I live, I will not see my building. I will not see the building where I live as I fly on top of that terrain. If I have a geospecific terrain, then if I fly over that terrain, I will be able to recognize my house, right? So that's the difference between geotypical and geospecific. When it comes to geospecific, it requires the integration of GIS file, the geographic information system files, and aggregate them together to create a virtual environment. And that's a role for a lot of tools that already exist out there that are supporting Unreal by creating content for Unreal Engine, as you can see on that slide here. But what's happening when you don't have your GIS files, right? When you don't want to build these environments yourself, that's when leveraging existing data set is super important. And we didn't invent formats. We didn't, had a crystal ball and decide to, reinvent the wheel and redefine a new format. We went and sat with some of the experts that are doing that already. We are close to the OGC. We're actually a member of the OGC, the Open Geographical Consortium, as well as the USGIF, the US Geointelligence Foundation. And in these two groups, there are a couple of consensus that are super important. And basically, and in a nutshell, there are 3 main formats that people want to interact with when they're building simulators these days. The Esri maps, the Esri ArcGIS maps SDK, as well as the CDB, the common database, as well as the 3D tiles. And all these formats have different benefits and different roles and different pros and cons. And we didn't want or couldn't, decide for you, right? So we decided to make sure that no matter what format you decide to use, there's a path for you to use it into Unreal. And again, that's part of the demo that Alban will show you in a bit. I talked briefly about deployment earlier, and I won't dive into that more right now, but if you want, during our conversation after, we can jump on more details about this. Specifically, we can talk about our support of the OpenXR Consortium and what we're doing along these lines. I mentioned the domes and the work that we can do with NDisplay. Same thing, we can dive a little bit more in our session after the demo. When it comes to deployment, cloud-based deployment is super important for all the players in the simulation community. And for different reasons, either to leverage very large install base of computers for massive deployment of very complex simulation systems, or also to make sure that IT work is simplified with deployments that you want to do in places where you can't install what you want on computers, or when you can't have the right GPU capabilities on some specific parks of computers that you can't really manage yourself, right? So that's where the distributed, the online capabilities and this distribution that we can do either through AWS, Google Cloud, Azure, is allowing users to leverage our pixel streaming capability from anywhere they are. And that was actually a demo that we presented in December last year during the simulation conference called IETSEC, where we demonstrated a project called Project Anywhere. In Project Anywhere, all the guests to that conference, the IETSEC conference, were able to, from their computers or from their mobile phone or from their tablet, anywhere they were in the world, to connect to an application that was an Unreal-based application running a geospecific terrain, a geotypical terrain, and loading it directly into their application using pixel streaming. So we mentioned briefly the dynamics of the objects and the simulation of these dynamic objects. The co-simulation is an essential part of the philosophy in Unreal. We don't want to lock you or to provide a solution that is an all-in-one solution. We want to make sure that you have the ability to connect your tools with Unreal, and that's part of that vision here. These examples that we listed in the chart earlier are represented here as well. One of the last points I have before we jump to the demonstration is to also keep in mind that no matter what you want to build on top of Unreal or around Unreal, to extend it, to customize, or to automate some tasks around Unreal Engine, you can do it. You can do it yourself. The API is open. The source code is free. It's available for everybody, and you can download it today. It's on GitHub, and that's the right place to to download it and to have a look at it. So when we are connecting with the simulation community, when we're building that ecosystem, that's also one place where all these builders and creators and inventors of solutions can go to download everything that they need around Unreal to amplify it if they need to. And some other people are amplifying it and are supported by Epic directly. That's the mega grant concept that some of you may have heard about already. It's described here. In the recent years, more than 8 million have been spent by Epic and awarded by Epic to simulation dedicated applications. It gives you a feel of the involvement and the dedications that Epic has towards this simulation community. And there's a reason for that. As you can see here, the simulation community is changing quite a lot. There are new drivers to the next generation of simulators that are being built. And between the progression of the XR type of applications, the need for more deployable and more reconfigurable training systems, we've seen a lot of new drivers pushing towards an evolution of the simulation domain. Also in the need for more realistic environments, which is not necessarily needed when you're training humans, but when you're training machines. As a matter of fact, it's strange paradigm, but as a human, we can observe an image and say that if we see some white vertical lines in front of us on a screen, we can very easily interpret them as rain, for example. Whereas a computerized system with an electro-optic device like a camera or digital camera, observing that same scene will say, "Hey, yeah, that's cool. I see vertical lines," but it won't interpret that as rain, as the drops of rain going to the objective of a camera. So you need to go to an extra level of fidelity when you're actually training machines compared to training humans. So the need for more realistic representation of your environment is growing in the simulation domain. So the simulation community provides a very strong and stable working environment, and there is a big need. We hear every week about new companies in the simulation domain coming to Epic or to our partners or friends asking for skilled individuals on Unreal. And if you're looking for a career change or a career shift, that can be a very good place to look at. So no matter what you're working on today, if you're working on applications that are Unreal based, and if you're developed your skill set around Unreal and looking for your next gig, that might be an interesting path to look at because there's a lot of needs. All right, so I'm done with the presentation part of our conversation today, and I want to take a quick time here to pause for a bit and see if we have any specific questions that we want to handle right now. And if not, it would be the right time to jump to a more interactive sessions with the demos that Alban prepared for us today.
Thank you so much, Seb. Let's see. Taking a quick glance, we have some general questions. They're more general in regards to the tools and some specific ones. So I think we can leave all of them for later on during the Q&A section and head over into Alban's demonstration here.
Excellent. So Alban, the floor is yours now.
Okay, thank you. So do you see my screen? Is it okay?
Just a moment, Alban.
Yes, we'll wait.
All right. Yes, we're good to go.
Yes, good to go. Sorry. So I will start by apologizing myself for my English, but let's say I'm French, so I'm working every day to improve it, but you will hear my strong accent anyway. So my goal today is to quickly demonstrate you how it is quick and easy to create an Unreal world with an accurate lighting, because in simulation we are searching for accuracy, and accurate lighting along with a concrete georeference system. And once we will have set up this environment, we will be able to inject into this environment some data set from S3 and Cesium. So I will go live and start by creating a game project. I start with an empty template. It's not mandatory to have something better. And blueprint, it's fine for now. And I will just name this project simulation demo and fix my typo. And that's all. Project is creating. We need to wait a little bit.
Alban, sorry to interrupt.
Yeah?
Could you change one setting in your OBS instance so that we can see your mouse cursor?
Okay, no problem. Yes, for sure, it would be better. Right screen properties.
Should be in the scene.
Yeah, yes, I got it. You see it now?
Yes, thank you.
Okay, sorry. It's better with it, yeah. So first, we will start by setting some specific plugin and some specific project settings. So I will start to go to my plugin page and enable some plugins. First one is the sun position calculator. It's something which is provided by Epic Games, but which is not very well known. And this plugin allows you to put your sky light at an accurate location depending on your position on Earth and time of day. So we'll start by enabling this one. Another one, we need to enable just for the demonstration is the editor scripting utilities, because we will use some inside editor widgets. And just for my computer, I will disable SteamVR just because I have a headset connected, not connected, and if it's not connected, I can have some error message, not important for normal purpose. So that's all for the plugin we need for now. And we need to, since we are there, change two things in our project settings. I will go quite fast. Victor, this video will be recorded and available afterwards, so you will have time to look at it afterwards. So first thing we need to set in our case is to extend the default luminance range in auto exposure. Why? Because we will work with a physically accurate sun, which has a very high luminance value. And if we don't set that, we will have a bad lighting setup. The other one is, since we will using the sky atmosphere, it's better to enable the correlation between the sky atmosphere and the haze fog. Yes, that's all. Our project is set, and I can just restart. I will not restart, but I will close it, just because we will need to bring some additional content in our project today. So my project is created on my hard drive, and I will add 3 plugins for the purpose of this demo. First one is Argis, second one is Cesium, and third one is a georeferencing one made by Epic, and that will be available for inside next version of Unreal. So I just copy it to my project folder, and once again for the demonstration, I craft a little terrain to speak about georeferencing. So I will bring this dataset into my project. That's all I need to set up. So read not that one. If I go to my demo and open once again my project, it will load all these plugins. Wait a little bit. Okay, everything is set up, not needed anymore. Okay, by default, the Unreal start with the old sky system and some auto actor. We don't need that today. So we will remove everything except our floor and the player start. Can delete everything. It's of course it's dark. And we will start by placing some actor. First one is the sun sky. The sun sky actor comes when enabling the sun's positioner plugin. And it's a blueprint. I will describe it afterward, but it's a blueprint that already aggregates the basic component for your sky, meaning the atmosphere, the sunlight, the skylight, and a compass, just to be sure that you are pointing to the north. If you just do that, you have your physically based sky, but you still notice that there is a black part at the bottom of your screen. This black part is, normally you should have geometry there. You should have a terrain, you should have anything you want, and it should be hidden by the terrain, and you just see the atmosphere. So if you want to get rid of this one, in that case, you can just place a fog, an exponential X fog, and you will have a blue, I would say, blue gradient to this. So let's have a look at what is a sun sky actor. The advantage of sun sky actor is there are properties such as latitude, longitude, and time zone, and also day and month value along with the solar time. And when you move your time of day, you see your sun is, of course, I can go there and move my sun to the sky. So it's strange now, but we will fix it very quickly. So what can I add? No, it's good. We just to speak a little bit about shadows, I will start by placing a cube, just to have some basic geometry on that one. I will expand floor to to make it not 100. Make it wider. Not it's live. Okay, and make my cube having something like an house dimension. So let's say I have a terrain with a house. Oh, that's good. If I go backward a little bit, you will see that after a time my shadow disappears. It's not good, and I'm not very far from the house. So I need to make some settings to the default sun sky actor to make sure that everything is better. So first thing, we need to edit our directional light, the sun, and give it a good physical value for this luminance. And for the sun, it's 120 lux. It gives a good, stronger light. And other thing, we can go to the shadow settings, and you will notice that by default, expressed in centimeter, by default, the range is only 2000 meters. That's why my shadows disappear very fast. So just add a bunch of zero, and I have something very far. I set 2 kilometers. But when you do that, your cascaded shadows setup is wrong. You have some blurry stuff. And we can fix that by working on the distribution exponent. And if you raise this value, you will have crisper shadows when you are farther. So with that set, I can have crisp shadows that goes from very far. Okay, so when editing the sun sky and going, for instance, to a specific time of day, let's say 18 hours, you see this strange behavior in the sky. It's because the fog is the fog behavior related to directional scattering is on top of the sun sky atmosphere scattering, and you will need to clear that. For that, we go to the exponential fog. Of course, if I remove it, I have a nice atmosphere. It's why the fog is making some issues. And for that, we just go to the directional in scattering color and set it to black. Then we discarded this value. If we enable and disable the fog, we see at the horizon a small gradient for coloring the fog to the sky. And if you want to adjust it, you can play with the haze fall off to have something crisper, or I would say more polluted, more dirty. So that this one is really artistic. So let's set to 1 for now. Okay. So we have something which is quite well. If I test for another values of time of day, I have something nice at noon and something nice at sunset, and during night, okay, it's dark. But if I wait a little bit, it's a little bit long because the A exposure, the automatic A exposure takes time to occur, and why? I have something very clear at night. It's not what I want. So we need to also control the way our A exposure is working. So for that, we need to add a post-process volume to our scene and make it the global post-process volume by setting it as an infinite extent, and go to the exposure setting of this post-process. In order to work faster, we can raise speed, A adaptation speed there. It will go, of course, very fast, too fast, but it's just for setting up our parameter. So if I go to noon and go back to night, I have something very fast to set up. And now what we need to do is to tell the system, not this one, this guy, that during night we don't want our eye to adapt too much to darkness. And for doing that, we can clamp the lower exposure value and have something which is quite dark at night. And with that down, you can have something which is consistent from day to night. Okay. Is there something else? No. Okay, so right now we have a sun. We forgot something important, which is the moon. Currently, the sun sky system doesn't come with a moon, but it's very straightforward to add one. We will add a directional light to our scene. Let's rename it to moon. And the moon is very specific. It has a very low intensity. And a full moon is around 3 lux for intensity. So you can add this light intensity to 3 lux. And yes, I've put a moon somewhere, but I don't know where it is. And I will need to move it. Usually, when you are working with a directional light in Unreal, you press Ctrl L and have this nice gizmo to tune your light. When you are using the sun sky, the main light is driven by time of day and not your actual gizmo. So we need to find a way to give a good orientation to our moon. It's a simple trick. We place our sun at a specific location. We go to this light, copy the rotation, go to the moon, paste the rotation, and here we have the moon placed right here. Of course, we don't see it, so well, we move the sun further, and we should have the moon. Why?
Because it's live, and things doesn't always go as you want it to.
Sorry, yeah, because it's live. We'll try another one. Okay, put my sun there. Oh, I think I copied the wrong rotation. Paste and go to sunset. Okay, but yesterday she was there yesterday. Well, anyway, we will go on and try to fix it afterward. Oh, yes, I remember. I forgot two important things. When creating the moon, I just consider it as a directional light, and I didn't tell the system that it was part of the sky atmosphere. I forgot to do that. Sorry. Of course, it's light. And for that, we need to go to the atmosphere and cloud setting and say that the moon will affect the atmosphere, and that his index will be the second index, 0 being for the sun. And now, since I do that, I can see the moon on the sky. Whew, sorry. It was fun. Now, if we move the sky, we can have something at night with the moon. Of course, you can imagine setting your moon direction using additional script to have something like actual moon phases, or probably create a small sphere to have another model. And so, while doing that, we are set, and we have something good with sun, moon, time of day, good shadows, and we can save our current level as let's create a folder first, call it levels, and name this outdoor. Okay, that was the first part. Victor, do we have any questions so far?
Not specific in regards to the previous part of your... Oh, let's see here. Yes, we do actually. Batsurai Biri asked, did you add the ArchGIS plugin as part of the 3 plugins you added?
Yes. I have. I will explain it how I get it afterwards. It's publicly available on R3 ArcGIS, but up to now, what I did doesn't require this plugin. The only thing you see is because I put this plugin in my project plugin folder, this plugin gets loaded, and I've got this extra ArcGIS button along with this extra Cesium window there. But we will cover that later on. Yes, last thing, this message related to lighting. It's important. When we are doing live simulation, we are lighting our environment in real time. We are not baking lights, something like that. So the moon should be set to movable. With that done, this message will disappear, and we will not have to compute and bake our light maps. Yeah. Other
So-
questions, Victor or Seb? Yeah.
Yeah, up to now, there's really nothing simulation specific, right? This can apply to video game or any application. But in the simulation industry, we need more, right? We need to know where we are, where the scene is taking place, and that's the part I think where the georeferencing plugin becomes very handy. Alban, do you wanna dive a bit more on that specific
Yeah.
point?
Yeah. So at the beginning of this demo, I grabbed into this project the georeferencing plugin. This is a plugin I made, which is currently available on GitHub, but on early stage. This one is a current state of plugin, and it will be part of Unreal Engine 4.27. So you will be able to use it in our projects very soon. And so when you do that, you have access to a mean to bring some actual location on Earth for your environment. So I will start by saving my current level as a new level called georeferencing. And we don't need this floor and building anymore. We will use another asset I brought to the engine when preparing it, and I drop it in my scene. I make sure that is placed around the origin, and we need to go a little bit faster because we are going wider. So I took a random nice country, you might probably recognize it, and it's a one scale terrain for France. And it's made from geospatial data. I have a digital elevation model, texturing, and so on. It's very low level terrain, but it's just to illustrate what I want to do. When I created this terrain, I made it some precisely located at one origin I know on Earth. The origin of this terrain is at some coordinates I really know it. So if I look backwards, you will notice two things. My terrain is flat, but the Earth is round. Okay. And so the sky atmosphere is also round. And we have this crazy stuff that my terrain is going into the sky atmosphere. It's normal, it's exaggerated there. It was just to illustrate. This flat Earth mode is more for small databases of 1 to 2 to 500 kilometers, but not that scale. We also notice this strange blue thing, and this blue thing is related to the exponential haze fog. It works well when you are close to the ground, but not when you are in space. So when you are trying to make bigger environments, get rid of it and consider the sky atmosphere will do the fog for you.
Alban, quick question for you. The content that you're showing here is meant for referencing placement here, but you don't really need to have it there, do you?
What do you need to? Oh, the terrain. No, it's just a random terrain. You can do it with any kind of Unreal terrain you would like to geo-terrain.
So it could be basically any primitives or any mesh that we would use there instead of having an actual terrain, correct?
Yes, you could take another floor, make it wider,
Good. So
and
it's
say, okay,
important.
this one is my terrain.
Yeah, it's important to know that you don't need to pre-construct, and get GIS data and elevation from a specific region to do that. It's just to give you a reference point that you would dictate as having the proper geo coordinates to start your application.
Yeah, that's right. You can georeference any Unreal database, even if you don't create it by geospatial data. So, in order to define our georeferencing in why my plugin is not shown? Why? Settings plugin, georeferencing. Cesium is there. Why is it not showing? I need to fix it because it should have brought me another component. So I will close and open it again just to be sure. I have it there. Good.
So while you're reopening, we had a couple of questions here about the two main plugins that you're using today, and I'll take care of these as you're relaunching the application.
Yeah, thank you.
So some questions came to
It's
us.
ready.
The ArcGIS, the Esri plugin for the ArcGIS Maps SDK, as well as the Cesium for Unreal plugin in terms of availability. So just to restate that the ArcGIS, the Esri ArcGIS Maps SDK plugin for Unreal Engine is already available as a beta on the beta program from Esri. We will add links after the fact to the conversation, so you have all these links. We will also put the link on the preview page for the Cesium plugin. The Cesium plugin will be available for everyone as of the 30th of March. So the wait is almost over, right? If you currently had it, but everything that Alban is using today will be in your hands like at the latest on the 30th of March. You already can download your Esri plugin. It will work directly based on what Alban will demonstrate in a bit. And from the Cesium plugin perspective, 30th of March is your D date. When it comes to the GeoCoordinate plugin that Alban will demonstrate in a second, is already available on GitHub for everybody on the Unreal Engine plugins on GitHub directly. We will share that link as well. Sorry, go ahead, Alban.
Yeah, no problem. Related to GitHub, the one currently on GitHub is the oldest version, but I will make it go to GitHub very, very soon, the newest version. So anyway, I don't know what went bad, but now I have my plugin loaded correctly, and I have a new kind of actor, which is the georeferencing system. I can just grab it, drop it in my level, and there you can define what is your georeferencing. We have two modes, flat planet and round planet. In that case, my terrain is flat. I would say it's a projected like a 2D map. And we are in a case of flat planet. We will see the round planet case later. If you are aware about geospatial data, you know that some projection system and every coordinate system has a nice name. There are the EPSG number, you have the well-known text, you have the proj string and so on. I will not elaborate about that today, but when I created this terrain, I asked that my, I would say that I'm located in France, and in France there are two UTM zones. First, the one I use is the UTM zone 31 North. Simulation savvy people know this zone, and I just need to declare that I'm working on this EPSG coordinate system. It means UTM 31 North. The geographic one is for when you are expressing your coordinate in latitude and longitude, and this one, 3326, is the one for WGS 84. So sorry about it. And now I have, one click. Where is my location? Where is my initial terrain location? When I created terrain, I put the 00 origin, which is a 00 of Unreal, at one specific location, which was expressed in that coordinate system at 500,000 and 5,500,000. It's big number, but it's classical WGS number location. So that's all. We have defined that our Unreal origin is at a specific location on Earth, expressed by using these coordinates in this projected coordinate system. That's all. Related to SunSky, the SunSky still needs to be located on Earth. So in that case, we have to make something consistent, and I translated this coordinate into latitude and longitude using, I would say, an online coordinate translator. It's very straightforward, and its time zone is GMT plus 1. What is the north offset? If I zoom on the compass mesh, you have a compass. I'm working and really moving very fast. That gives north to the right, and in fact, my north is in front of me. So I need to turn my SunSky to make it pointing correctly to the north. So in that case, I need to say, okay, north is minus 90 degrees. Right. And when I do that, and I take the SunSky and change the time of day, you will see my sun at west, at sunset at west, and so on. You know the story. Okay, so we have set up. So up to now, I just made some demonstration, and I didn't prove you that we were on a right location. So if I now show my plugin content and go to the georeferencing plugin content, we provide some utility widgets that you can run as an editor utility widget, and it displays your actual camera location in the engine coordinate, in the projected coordinate system of choice we defined sooner, in latitude, longitude, and also in geocentric coordinate. Geocentric is a particular frame which is also called ECEF, which is centered at the center of Earth. And you can also point some coordinates, some point with your mouse, and you will get in the bottom part of it the coordinate you are pointing to it. So in that case, if I try to point something around Paris, texture is quite ugly, but there seems to be Paris, and 3 degree longitude, 49 latitude, it's fine. Okay, and in fact, it was not Paris at all. Paris is there. Here we go. That was the first proof of the geo-coordinate system. But we can add other things to it. We provide also an UI, which is a kind of status bar that displays some your viewport coordinate, and it's very straightforward to add it to your environment. You go to your level blueprint and Begin Play. You create that widget. Create widget of which kind? This geographic status bar with player controller, and you just add it to the viewport. Yeah, that's all. Compile, save, and now if I click play, I go to runtime. I'm below the terrain, of course, because I didn't change my player start. So let's go there and make my player start there. Snap object to view, play, and no. Okay, here we are. And if I go to full screen to make it more visible, you see at runtime, bottom of the screen, that we are located at some point. I don't move, but it's quite normal because I didn't set up a pawn to move correctly with that scale. So I need to make a pawn that will enable us to go faster. So let's create a blueprint component. It's classical stuff. Let's create a game mode. I will call it simulation.
The reason for you to have that pawn with that very high multiplier for your movement is because suddenly your application is real scale, right? Your scale is 1-to-1, and the environment that you're taking is multi-thousands of kilometers now.
Yeah, that's why I need to go very fast.
The pace that you will get, something that's more modest in the displacements that you will get. That's why we're creating that enhanced pawn to move your viewpoint or your player faster.
Yeah. So in that case, I just go to the movement component and add a bunch of zeros there. It's quick and dirty. You should have actual relevant speed, or make something clever that you change the speed based on altitude, something like that. You can go on anywhere. We created a pawn more clever than that. That was changing his speed based on altitude. So now my simulation game mode will use this pawn simulation pawn as a base pawn. Okay, and need to go to the project settings, maps and mode, and ask to use my simulation game mode. And let's say I can start with georeferenced terrain.
And this is typical Unreal framework stuff
yeah.
that it applies to pretty much anything you'd use the editor for.
Okay, and now I have something which is going crazy fast, and I can check that my coordinates are changing dynamically. And I can also see that I'm very high from the ground. Okay, and next thing I wanted to showcase related to proving that we are in a fully georeference model is with this plugin, we will provide a location probe. It's a blueprint that you can drag at any location in your scene. So I just dropped it in on the sky, so whatever. And these probes, when I click on play, you notice that it will display, zoom, it will display its actual coordinates, the actor coordinate expressed in the 3 coordinate system we had before. First one being the projected one, the second one latitude, longitude, and third one the geocentric one. It's very straightforward to make some point of interest and to check that your level is at the right location. And I just wanted to illustrate, if you look at this blueprint, what it does. It has a location widget, which is a probe text, and everything is computed there. It's basically some strings, and if you go to the graphs, it's the interesting part of the geo referencing plugin. It's how it works. So at each tick on my probe, I grab a georeferencing system. You just write that geographic geographic system. Well, anyway, I don't know why I got it, and when you have access to this guy, you can go to georeferencing, and you have different functions that will enable you to convert your coordinates at runtime. You can go from engine to geocentric, engine to projected, and once you are in geocentric or projected, you can go to geographic, latitude, longitude, and back and forth, and so on. So what I do that is I take my engine location, I express it in a projected coordinate system, and I set the text of block project. And this projected coordinate, after that, I convert them to geographic, latitude, longitude, and I set text block with latitude, longitude, and same with projected to geocentric. So you have access to that in Blueprint, but also in C++. So if you want to make accurate conversion, or if you have incoming actors coming from, let's say, a sky tracker system, when you get aircraft location expressed in latitude, longitude, you just spawn this Blueprint node, and automatically it will put your actor in the actual Unreal location, which is consistent to the location you defined before. Last thing you may probably notice that in our probe we have 3 arrows. It's the east and north and up vector. If you have played with large database for simulation and you reach high latitude, you will notice that when you are dealing with projected coordinate system, the northing is not the y vector. You have a slight angle. It could be very little, but in my former life, we had we made a shooting simulator for a BMP-3, which is a military vehicle, and there were a bug in our simulator when we confused the northing and the y-axis, and the small error angle make us miss our target when shooting at target. So if you are doing serious simulation, you probably know what I mean, and this plugin will take care of that. So that's all for the second part, where I explain about how to georeference a world. So do we have other question right now?
Sorry, go ahead, Victor.
No, I was just going to say, yes, we do. Seb, please go ahead.
Yeah, sure. I mean, we have a couple of questions that I think we can handle further down the road about the plugins. But one thing that's interesting here, I mean, we already went 2 steps, right? First step is we created a project out of nowhere, and we created that base project. And the only thing we did so far is we injected the GeoCoordinate plugin into our project, and we demonstrated how it reacts and what are the potential of the plugin at the moment. But we showed a lot of things within the editor. How can it be used in applications in real time? What's the next step in that, Alban?
So in real time, if you are creating your own plugin, you can add a dependency to it in C++. All the source file of georeferencing are public, of course, and you can have access to all the include, and you can link and depend on this plugin to call the conversion system by yourself. And if you are not a C++ programmer, as I demonstrated, you have blueprints node that do exactly the same. I didn't went into all the nodes, but if I go there, we have some additional methods to compute the east-north-up vector. We have, this one is very specific, we can get the tangent transformation at one specific point on Earth if you have a specific inset or level you want to place a specific location in Earth, because we are thinking round. We can go to each side of the Earth. So this plugin will help you to do all that boring computation, and it will be part of for 427. One last concern is that currently, it's a very accurate plugin. We did all our computation in double precision, but it's running on 426 there. You see it. I'm not cheating at any point, and we are able to do that by some tricks, because currently the engine is on single precision, and in order to be able to deal with accurate 64 bits precision, we created some intermediate shapes, because we cannot use double in Blueprint in Unreal 4. And once Unreal 5 will be there, this plugin will change, and everything will be ported to the new 64-bit system of Unreal 5, and it will make our life easier. You will have more access to internal double precision structure in Blueprint. You will not be able to rely on rebasing to deal with your large geospatial coordinate and so on. So right now, you can go with Unreal 4 and make your geospatial application. It's not a matter. You have everything. You have all the tools you need. And in the future, we plan to support double precision in Unreal. That will save a lot of concern.
Okay, so just to summarize, and before we jump to the next part, a very important point here that you raised, the fact that you had to jump through hoops in the creation of this plugin is linked to the fact that 64 bits is only coming in Unreal Engine 5. But all these hoops that you jumped through for the creation of the plugin allows users to today have the right level of precision out of the plugin directly in their computations. So they can already rely on that GeoCoordinate plugin today. And the evolution that will come in the next generation of Unreal will simplify all the things that we do behind the scene. But as a user perspective, the realism and the fidelity of the coordinates that they want to use is already there with this plugin. So that's a very important point. And we could take some question at that point, Victor, if you want to go through them, or we can continue and start seeing. Now that we established the main structure of this demo, it will be time to jump on the actual plugins. Victor, do you want to continue with the demo, or jump to some question at that point?
Yeah, let's go with the demo. We might even tackle some of them through Alban's presentation. And don't worry, everyone, we're getting your questions, and we will make sure that we cover as many as we can during Q&A. We got time today, so Alban, please continue.
So really, I think now that we demonstrated something flat and of limited size, let's go crazy and let's do what we always wanted to do when we started on this simulation journey at Epic, is to answer the big question that we always had. When I started at Epic, the biggest question that I had from simulation developers was, yeah, that's cool, that's pretty interesting, this game engine, but how big of a terrain can you ingest into Unreal? And we were saying, well, there's no limit. You can get the terrain that you want. You can integrate a very large terrain as much as you want. And our answer was good, but not good enough, right? We needed to demonstrate something to prove our point and to say, well, you know what? If the world is enough for you, you will be fine. And that's what we're going to demonstrate now. It's the answer to this big question of how big of a terrain can we swallow in Unreal today? And the world, the planet Earth is a good answer to that. So Alban, let's have a look at the Esri ArcGIS Map SDK plugin that you installed on your project, and let's see how you implement that into your application. Because at that point, that's only the missing part, and you will all see from an existing project how quickly it goes to start streaming. Go ahead.
And yes, flat terrain are for kids, and now it's time to switch to grown-up terrains. So I will remove everything. I keep my lighting setup with my atmosphere, and I just call the Esri plugin there by clicking on it. It will add an ArcGIS map controller to my level. And now if I select it, I have access to a specific panel when I can select what kind of dataset I want to see in Unreal. So we have two options. First one being a local scene. It means a small scene which is around a specific location, but with a limited map extent. When you explain it in meter, for instance, I want something 1 kilometer by 1 kilometer. But if you want to go further, you can make something big using a global scene, and that would be the full world. So I will make something around New York. So I need to enter coordinate from New York. I will also say that my camera will start at 3,000 meters from the ground. And now I select my base dataset. I can have world imagery, streets, other kind of Esri geospatial layer, but I will just be something living with the world imagery. And of course, I want terrain elevation. I don't like when things are flat. So I just press on it, and now if I click play, just by doing that, I have my Earth in Esri. And I can go anywhere from the ground and have nothing on my computer. Everything is streamed in from the Esri website. And I can go up to the sky and to the globe. Yeah. So I'm a little bit stuck. It happens sometime, probably a garbage collection, something like that. It will come live very soon. It's not crashing. Yes, it was just frozen.
While you're demonstrating that, I want to handle a question that we had about what is the type of Esri ArcGIS online content that you can display thanks to this plugin. And the interesting point is that as you look into the structure here of the layers that Alban is showing right now, you can use the API key from ArcGIS to enter any type of web maps, web scene, layers, items, or services to inject them into your application here. So if you'd be to go online or use the API keys that you're using for your existing project in ArcGIS, you will be able to just copy your identifier here, your key here, and suddenly see all the content that you're dealing with traditionally in the context of ArcGIS from Esri. So anything that you have that exists in your environment, you'll be able to look at there. So we're currently running the second beta of this plugin that has been released in February this year, so very recently. The team from Esri is planning on making it out of beta, in the next future, and there will be more dates announced by Esri in the coming months, I believe. Currently, if you go to the developers server from Esri on the arcgis.com website, you will get access to the entire documentation of the plugin, and will be able to download it and download a sample project that contains everything that Alban has to create manually to be able to start your plugin, to be able to start your application. So everything that we've done today, you can find directly from downloading the plugin, and you will get access to a very complete and running project in Unreal Engine that you will be able to directly load on your system and customize the way you want. So no, hand creation is needed at that point. You will be able to do a lot of things by yourself, just downloading the plugin.
Yeah, thank you. So up to now we were just using the basic base map, but with ArcGIS you can add other layers of dataset, of course using your API key. But some of these datasets are free to use, and that's the case for the New York, USA. So I will just quickly add another layer, which is building, and now it happens there. And I researched some additional, let's say, layers for the demo. So I will go very quick and paste their URL there. It's the transit layer for New York, and you can also add population density using this URL. Could have found it on the Esri website, and let's call it pop. Add layer. We have 3 layers. One thing we need to do, it's not mandatory, but when you go to world setting, Esri provide a sample game mode that use a sample, default pawn, which is sample default pawn, which provided by Esri. So I encourage you in using this pawn for better motion. And now it's the same dataset, but it's not the same dataset, it's the same level, but with additional dataset when you can see the population density along with the traffic points in New York and the buildings. So in that case, it's the 3 layers I took are very basis. It's let's say gray cubes. But if you go to some cities like Montreal, you can have full photogrammetry assets with your actual nice building. And yeah, and you can see my bottom status bar is still there. I still have my coordinate. I'm able to do whatever I want with this data set. Okay.
Yeah, thanks. That gave a lot more context than just the Earth's surface and the elevation. So yeah, that answers one of the questions that we had on that topic about the types of databases that you can load.
Yeah, I'm not able to monitor the questions while demoing. It's a bit complicated, so I trust you. So let's switch to the other part and go to Cesium. I start again from my georeference world. I remove terrain and probe.
So what you're showing now is really restarting from the same point where we were when we branched to the Esri ArcGIS plugin, and you're taking the same core of a project that you had before, and starting to use the Cesium plugin, the one that we mentioned will be released on the 30th of March.
Yeah.
Yeah, go ahead.
That's all. So well, we are speaking a lot, so it takes much time, but you can create all of what I did in 10 to 15 minutes. It's very, very easy. So with Cesium, you add not a button, but an additional window, and you are welcomed by a panel that enables you to create a Cesium ion use your own account if you have one. So in our case, I will use our Epigame account with our magic password. Got it. And like for the other one, we have a quick add feature that enables us to choose a base map. So in that case, we want the world and we want to use the big maps aerial imagery, but you can also use label imagery or road imagery if you're doing something related to mapping or driving on maps and so. I press on plus and everything is added automatically. And on top of that, if you are connected to your Cesium Ion account, and you can see all the assets that are currently related to your account at Cesium. And in my case, I have some photogrammetry assets in Melbourne, and I want also add it to the level. So as long as you have assets, 3D tiles assets, you can use that panel to bring them to your scene. So up to now, we don't see anything because we didn't made any setting related to georeference. We need to tell Cesium where is my Unreal location once again for the origin. So let's. Oh yes, I forgot to say one thing. If you go to Melbourne or probably to the world terrain, you can see it's an actor with some properties, and in that case, we have two ways to bring 3D tiles assets to the scene. First one is when using the Ion server from Cesium, where basically you have an asset ID and an authorization token to have a look at it. And you can also use this URL to point not to an Ion server, but to an external server of your choice, or even to your local file on disk. So if you want to make 3D tiles outside of Ion, you are able to with Cesium. So let's switch to the georeference setting. We want to express our origin in latitude, longitude. So for those who know, Melbourne is something like this location. And if I do that, you probably notice that now we are still in the editor and we have the data streamed already streamed in. It's very interesting because you can stream the data right away, right in the editor without without having to press play. Last thing I didn't update, I forgot to update it also on the latest demo, is to the Unreal georeferencing system. We need to, in that case, switch to round planets. We need to say if we want to have UTM coordinate around Melbourne. Trust me, it is this guy for UTM South 55. And in that case, we will express the origin in not same as before, but latitude is clumped, of course. It's not the same order. And that's all. If you wanted to go to switch to a full geocentric or ECEF mode, you can just click on that. Means that origin is at planet center. It's basic definition of the ECES coordinate system. So let's say on an origin tangent to the Earth's surface. We did it for the georeferencing system. We need to do the same for the sun sky to have something very consistent with something very strange when your sun is at north at noon. I never went to the southern hemisphere, but trust me, it works. So I put the same settings, the right setting, and now I can just press play and have everything working. Yes. So I didn't rebase my player start, so I'm probably a little bit away, but now we have something within dataset, which is streaming in. So it takes some time because I'm at home with a computer connection, and moreover, three kids at home today. So my network, my bandwidth is not that bad, not that good. And of course, I have a default phone which is going very, very fast. So it's not the best way to demonstrate. But yeah, we are inside a full Earth system where we can go everywhere. Last thing I wanted to illustrate, if I go to one particular location far away from my origin, we'll notice that the horizon is not horizontal, for sure, because we are using a round Earth, and if you go far from your origin, you have this not balanced, but skewed horizon. And we have a way to fix it. Cesium provides a pawn, which is, if you search for a pawn, it's a globe-aware default pawn. If you create your own pawn, inheriting from it, let's call it Cesium pawn, and once again, go to his motion behavior, add a bunch of zeros to make it faster, and once again, create another game mode, which will be Cesium, and tell this game mode to use this Cesium pawn. Where is it? Yeah, Cesium pawn. Save everything, compile, and go in world setting and ask for using the Cesium game mode. We have something well set. I will go and define my start there. And that's all. Play again. We are starting once again. You can see the status bar with the actual location. We can go to our sun sky system, even at runtime, and make something in the morning, something nice in the morning. Yeah. And now, if we go anywhere on Earth, everything is streamed in on demand, and your horizon will always be horizontal. And you can go like that very far at any time. If you have seen the Anywhere demonstration, it's something which sounds similar. And yeah, that's all.
Thank you very much, Alban.
Yeah, very impressive.
That's really that really illustrates how simply you can go from very basic project to a point where you can start simulating environments. There are a lot of questions, Victor, I believe.
Yes, we've received plenty. And so if you both are ready, we can start diving into some of them.
Before we're jumping in the questions, something I would like to ask to our audience today is to using the same mechanism you had when you asked us all these questions. Can you let us know what you're dreaming of building in terms of simulation application? What's the most complex thing that you're dreaming of creating, and why is it that tricky? Our goal really is to try and understand where you're going, so that we know where to go next. Today we demonstrated two different ways of integrating an open and unlimited world into your applications, but we would love to see where you see the next big thing, and what is the biggest concern you have when it comes to simulation and the type of simulation you're building. Are you in civil aerospace? Are you in the medical domain? Are you in railways management or testing of systems? We're really curious about you, and that would be great if you can tell us a little bit more about what you dream of building. Now let's jump on the question if you want, Victor.
On that note, real quick, if you're watching the stream when we're not live, feel free to use the forum announcement post as the place for discussions post-stream. It's a great place for us where we can follow up and continue the conversation when we are no longer live. With that said, let's go ahead and dive into some of the questions, and we will start from the top. Thigis asked, when representing a simulation, I want to achieve an augmented reality tabletop use case while having a scaled down environment with WGS84. What approach should be used?
So, in that specific context, and that's I see Alban laughing because that's something we're working on currently with a specific mounted display for specific context. But it's not more complicated than building the sample that you have seen right now. So once you have your application, as we discussed earlier, the way you deploy your application is handled by Unreal, right? And in your compilation, once you're building your application, you can select what type of devices you will build upon. Obviously, no sky will be the best answer to your question. Put a very, very black sky because that's what you want for your augmented reality application. So make sure that you have the right light for your terrain. But the trick is, getting rid of that dome that you have around it, and your atmosphere will have to be handled properly to suppress that. You want to add to that, Alban, at that point?
Yeah, I didn't see any scaling value on this current beta from S3, so I don't know if it's possible to change. But for Cesium, you just take your tile set, you lower the scale, and it just works.
If you're using a stereo augmented reality device, essentially like a head-mounted display, I'm fairly certain you'd be able to just change the world to meters variable, which is a global setting. All that actually does is to change how far away the two virtual cameras are from each other, which, if you think about it in real life terms, that's actually why sort of an insect has a very small interpupillary distance, and that's actually what creates our sense of scale. And so we have that opportunity inside Unreal Engine to just change the world to meter scale, and that will actually adjust the perceived scale when you're viewing this using a stereo device such as a VR headset or a head-mounted augmented reality display. And that should actually work with the plugins as well, considering that you're actually not changing any world scale. You're just changing the way that we are perceiving what we have in the world. Let's move on to a question from Raul Passos, 1808. Applications often require online data reception to be more realistic. What are the ways of receiving data that you visualize that will facilitate this connection? Something like Live Link or USD files? ?
You want to take that one, Alban?
But yeah, but in that case, you know the terrain server, the terrain data provided by S3 or Cesium is already their own data with streaming capabilities. The only thing we do is getting this data and integrating them in Unreal as any other kind of geometry. They are live in a physics system and so on. And since it's just a layer of geometry in Unreal, you can get other sources of data in your Unreal level. You can use USD, for instance, because Unreal supports USD, and you can make some insets at some specific location on top of these data layers. It's very straightforward. You have to think you are not in a GIS tool. You are in Unreal Engine, which is a game engine, and you can mix everything. Just your imagination, your limit. Of course, in that case, if you imagine the amount of data to have the whole Earth at 50 centimeter scale for imagery, you cannot host it in your hard drive unless you have a very good hard drive and access to the data. So you need to rely on online services to do that. But if you are more interested in a smaller area, you can have it also in your hard drive or your local server, not relying to an internet connection, but just a local network to have this put in Unreal. And also for security issues, sometimes it's mandatory. We need to differentiate the hosting mechanism and the streaming mechanism and the rendering mechanism.
Next question comes from Nicholas FRM. What is the best way to simulate the real-world global map, say for the purpose of creating a strategy game, so that when the user clicks on a province and country, information pops up, etc.?
Same way Alban described the concept of interaction in your application. You can integrate on top of your environment the type of data sets that you want to map with your application, and using segments and specific locations that you want to predefine. You can outline any region of the map that you want, and like you would do in any interactors in Unreal, you will be able to point to a specific location, and this highlighted or this augmented terrain will react to either the entrance of a character on a specific territory or the presence of a collision with any region of your map. It will provide you a set of information that you would pre-register on your specific location.
And S3 is working on the future by bringing some spatial requests, because when you are in the geospatial industry, you have some vectors with some attributes and so on, and future will be to be able to make this request. But right now, I think there is a shapefile plugin in the marketplace when you can import your vector data and get the associated information. I didn't try it for a long time, but I think with the geo-referencing system, it should work and get you your geometry.
Next question comes from Figgis. What is the roadmap of the geolocation plugin?
First, to have it part of 427. Second, to make it switch to 64 bits. And third, everything you want, just express your needs and we will fulfill them.
Once again, going to point to the forums as a good place for suggestions, recommendations, and discussions around the topic.
Exactly. Yes. At the moment, it's part of the plugin that we distribute on GitHub, but moving forward, it will be part of the distribution of Unreal.
Let's see. Next question comes from Monocro. Since the slide mentioned it, are there any news on Cesium for Unreal Engine?
There are plenty of news. There's been a recent blog post on the Cesium website on that topic, defining more in detail the roadmap and the release timeframe, as we mentioned earlier. One thing that's important as well is that if you want to stay connected, they currently have on their website a registration form on which you can enlist yourself to make sure that you're up to date each time they're posting news on that specific topic.
I put the link on the chat on Twitch. Can probably do the same on YouTube.
Thanks, Alban. We'll try to gather some of them, and we can put them on the forum announcement post as well, under the resources section. Matthew Tremblay asked, in the simulation industry, we make extensive use of Esri formats. It would be great to have a seamless integration in Unreal Editor to be able to read-write these formats. Will this plugin allow that? I think that's a yes.
Well, currently that's a no.
Huh.
Sure. I mean, our goal with Unreal is to, at that point, consume the data set that are created by these fantastic generating tools that you use in the ArcGIS ecosystem, right? And that's how you create your content. That's how you create your maps and all your data set for ArcGIS. Same thing goes for 3D tiles. The Unreal Engine will be leveraging the content, and at this point will not be creating the content. There are pro tools and middleware that have been developed over years by all these partners, and we don't aim to replace it, but to actually consume the terrain data that are generated by them.
And probably, well, yes, you notice that we needed to press play to have the data streamed in the editor, and that currently a beta phase. And if there are a lot of requests from customers to have it available straight away in the editor, that's probably something that Esri can consider, and we can help them in implementing such a feature.
Next question comes from Chimera XR. How does photogrammetry work with Unreal? If I want to use a drone to send imagery to a VR headset, not in real time, can UE4 support it?
So Chimera XR, your question is fantastic. We love this question. It's really the way to go moving forward, right? I mean, remember at the beginning of our session when I mentioned that the evolution of the pipeline is super important. Well, traditionally, the sources of files that we're using to generate your virtual terrains was only linked to GIS files that were sometimes outdated, sometimes not containing all the right information, and that's a lack in the pipeline of creating your georeference environment. The use of photogrammetry is really where we collectively, as a community of simulation creators, see the future. The USGIF is talking about it. The OGC is talking about it. Everybody's talking about it. That's the subject. That's today's subject, right? How do you take photogrammetric elements and bring them to Unreal Engine? Well, the use of the Esri ArcGIS dataset, as well as the use of the 3D tiles dataset, allows you to do exactly that. And that's why in the terrains that you saw, for example, in the Cesium dataset, when Alban was flying over Melbourne, dataset that you saw there was direct photogrammetric assets coming from drones captures, right? And that's one of the beauty of this process, is that once you reach the format that you want, and once again, we're not creating the format dataset here, and in that example, we're just consuming the 3D tiles. But once you ingest your drone dataset into your 3D tiles, you can just load it into Unreal, and it will just work. That's part of the beauty of leveraging standards for us. It's making sure that no matter what format you use, it's ingested globally. One of the formats, the core formats that is super important in that process, is the GLTF format that Unreal supports natively, and it allows a strong acceleration of that pipeline as well. There will be more coming from Epic on photogrammetric ingestion into Unreal, but these are a couple of topics that we'll be able to talk to you more in the coming months, I believe.
Exciting. Next question comes from Martin Sporer. Is there already a multi-channel synchronization in Unreal Engine? Use cases for multi-channel projection systems.
So we alluded to the end display mechanism in Unreal, but I'll let Alban give you more detail on that specific topic.
Yeah. So in Unreal, we have a technology called NDisplay, which is basically doing everything you need to have a multi-channel visualization system. So basically, you have an host, a master, and several clients connected to the master. When everything is synchronized, the time is synchronized, all the properties are synchronized, and then you can even frame lock or gen lock your projection system using that technology. And you know where is it used? It's used in virtual production for all the big screen with LED panels everywhere. And you can define your camera location, and the system will automatically take into account your projection system shape if you are projected on a dome or a flat screen or something cylindrical. Anything you want, we support all the basic format, the standard format related to projector calibration. And the only thing you have to do is just create an Unreal application and enable the NDisplay plugin, set up a configuration file related to your projection system, and it just works. So you can take this geometry layer coming from S3 or Cesium, have it into your Unreal application, and make your flight simulation inside the dome. That's all.
Potentially invest in a rather large farm of computers who can handle.
Yes, for sure. Yeah. We can have several channels on the same computer, but if you are really looking for high performance, you should really have a cluster of computers.
Been some really cool demonstrations of the dome experience using NDisplay in Unreal Engine, even for live performances. There's plenty of content out there.
There was a demonstration on our booth at ITSEC in 2019.
Next question.
Before. Yeah, go ahead.
Sorry, Alban. Next question comes from Yvain Tisserand. I would like to know if you plan to develop things for virtual humans, having NPC that can be more easily controlled for simulation application, chatbot system, animation, locomotion.
There's a lot being done. I mean, we all seen the MetaHumans creator capabilities, and that's a great link to your question. I mean, if you didn't have a chance to look at it, search engine MetaHuman creator for Unreal Engine, you'll see a lot of information about it. And these humans, while being sometimes looking like overwhelming for developers, are actually pre-rigged, right? So you can use them directly in your application as simply as terrible avatars that you were using in the past, and manipulate them the same way. So the same logic of control applies, and allow you to, while using the same mechanism that you always had for chatbots and conversational avatars, create things that are way more realistic, allow you to have more more realistic interactions with these virtual humans. So that's a question that almost looked planted by us, but it's not planted by us. I hope I answered correctly to that question.
Yes, but I will add something. When you have your character inside Unreal, you have all the character animation tools that enables you to have your animation state machine, I would say, with all your based animation. But on top of that, you have the inverse kinematic system. When on top of any animation, you can drag your character hand and put it at a specific location to grab something and so on. You have all of these tools already in the engine.
Next question comes from John Graham, and I think we covered this, but when will Cesium be available?
Yeah, so same answer than earlier. If you missed it, it will be available on the 30th of March this year. So couple of weeks away from us. It's coming up. So if you want to be sure of being informed very early, you can register on the Cesium webpage to be part of their communications.
Next question comes from Martin Sporer again. Is Double Precision already launched?
Aman, you want to take that one?
Yes. It depends what you mean launched. If you mean that it's available for end user, I would say no. But if you mean are we working on it currently, the answer is yes, and it will be part of Unreal 5. But even if you don't want to wait for 5 to experiment it, Unreal 4 already comes with a rebasing mechanism, a rebasing system, and you can dynamically change your actor origin to have to be able to support large coordinate even using float precision. I did a webinar, we can probably point back to it, or it's available on Unreal Engine when working with geospatial data in Unreal Engine, something like that. And I explained this system and show an example of a rebasing actor that can trigger the rebasing system in Unreal automatically. This is a system which is used when you are doing world composition, but in fact you can use it at any point. It's just a matter of setting and translation offset, and all actors in Unreal react to this translation, and you can support large coordinates for now. But the rebasing comes with a cost. As long as when you do the rebasing, you have a small hike in your performance. So that's why 64-bit will save a lot of things. And our internal experiments so far prove that we will not suffer of any performance drop. So I'm waiting for it a lot.
Next question comes from Figgis again. Does this approach work well on a VR device such as the Quest?
Yeah, so as we pointed out earlier when we talked about AR, I mean in the Quest, which is VR, the same approach will apply, right? When you're building your application in Unreal, you will be able to build your application and generate it for different devices, the Quest included. And as long as you're connected and as long as you have the right data flow, you would be able to load your data set the best way possible in the Quest. You can also keep some data set local. If you have a data set that is local that you want to capture there, you can load your data set for your 3D tiles, for example, and held them locally on your Quest based on the terrain on which you want to operate your scenarios or your training environment.
Saw some chat around the possibility. I'm not sure if we received a specific question, but I was curious, do all the tools that we showed in Editor today also worked in a packaged version of the project?
Of course.
So not only editor time, also at runtime in a packaged project.
Yeah, of course.
Let's see. Next question comes from Marvin235. When importing data set of geographic location, how does the engine manage to create collisions for the models and the surface, and how does it perform with extra large objects?
Good point. I cannot answer for S3 because I didn't have a look at their internal stuff, but for Cesium, the collision meshes are built on demand when streaming in the engine on a separate thread, so it's not creating any spikes in the performance, and they are present in the and probably it's something similar with S3, but I'm not 100% sure.
Next question comes from Katrina K. Can you access global data outside of the continental US? I'm working on a project set in Sierra Leone, and the GIS information is challenging.
So the answer is yes. as long as the data set is available, and that's always a question of data set, right? We're not producing data and we're not, owning the data sets here in these two demos that we showed you. As long as the data set exists in your environment, either on the ArcGIS domain or on the Cesium domain, you'll be able to load it into Unreal Engine. And depending on the regions, you will have more or less detailed data set because you will have more or less detailed data set survey authorized in a country or in a region. But we can give you a couple of pointers in the forum. We will be able to give you more pointers towards the sources of data that we used here.
Yeah.
Another question from Marvin235. Can you compute a light/static shadow with this type, or is it recommended to keep the light immovable, or the light source as immovable?
No, it's not recommended because your dataset will be huge and your light map cost will be too demanding. Light map are well suited for interior stuff like that. But light maps are often needed for say that indirect lighting, and we are Lumen coming very soon. So you will have light map will be probably part of the past for some application.
Next question comes from Angry Baguette. With the actual plugin, do we have access to feature database attributes? Is it possible to have some interoperability with feature selection and modifying the appearance, for example?
So depending on how you set up your application, you have the ability layers by layers to have different treatments on the way you would display things, either for one plugin or the other. That's a very simple and short way of fixing that question. However, the complexity that you will be facing moving forward is the need to have very semantic content in your application. And the semantic metadata that is coming in all the descriptors of these terrains are really your best friends moving forward, right? So as the 3D tiles next is coming up, you will see more metadata that allow you to have specific treatment for your data set. As for the Esri ArcGIS, leveraging your layers will be a very good answer in the short term, and we'll see in the coming releases what are the best ways to interact with this content.
But I would add that something else. You are inside Unreal. You can write your own Unreal plugin, and if you click on one point and hit something in the geometry, you can get the actual location, latitude, longitude, or whatever, and take this location and from inside your plugin code, make a request to another geospatial data server and say, okay, please give me the vector from this layer at this location, and then give me the dataset. And you will get it in your plugin and use, let's say, an UMG widget to display it. On Anywhere, when we integrated a Sky aircraft tracking system, we made some web requests to another server to gather aircraft data and displayed it in Unreal. It was not in the plane itself. We took the information of that plane to make requests to another external server.
Next question comes from Stephen Hasselmore. Is content only loadable via, I think they are asking online, or can we self-host content?
I think the question is the content only loadable via Ion, or can we self-host content? For those who are not familiar with it, the Cesium Ion is the repository, basically the server from Cesium. It's a 3D tile server, if you want. And in the demo we gave you today, we connected to the Cesium Ion server directly into the application. There are three ways you can get your 3D tiles into the Cesium for Unreal plugin. You can get them from the Cesium Ion through the internet, exactly like Alban did today. You can have a local Cesium Ion server in location where you're at on your intranet. So you have your own little personal server. Or you can have your repository of 3D tiles organized on your computer, and these can be served directly into the plugin without requiring a specific Ion server, right? So 3 ways are possible. So the short answer is no. It is not only loadable via Ion, but it can be self-host contained.
All right, let's move on. We got a couple more here. Brian Windsor asked, is there an Ion database, now that I understand what Ion is, and it's not a typo, is there an Ion database you can download locally, or do you have to create it yourself?
So yeah, you can use a free registration to the Cesium Ion database and start using it today. Or you can, as we mentioned, create your own 3D tiles, putting together the right pipeline on your end if you want to control the content from A to Z, right? You can use a repository, which is usable today, or you can find another way. So that's pretty much the answer there.
Next question comes from Milan Petrovsky. What is the best way to simulate cities that doesn't have aerial photogrammetry? Doesn't need to be the exactly same buildings, but I need the layout with generic buildings. OSM I saw is one way to go. Is there another way?
So as you pointed out, the OpenStreetMap is a type of layer that you can easily get data. So you make sure that this way you got your elevation and footprint of buildings and road network correctly defined. That can be a very simple way that works, in different environments easily. And on your OSM dataset, you can apply any treatment that you want in the look and feel of your application. So you can give it a feel of randomized distributed shaders, so that your buildings have a feel of buildings and less of a gradient of colors that you want to use. But there might be other ways. Alban, do you have any ideas around it?
Oh yes, I have better than that. There is already a free plugin on the marketplace that does it for you. It's Virtuvio from S3, and it's enable you to generate cities right into Unreal. You can go. I put it on the chat for Twitch and YouTube, and you can have a look at it if you want.
Thanks.
Thank you, Alban. See, next question comes from Comrade in Charms. With the georeferencing plugin, could you describe how one would warp a flat mesh with a given CRS to curved mesh?
Oh, nice one. I think there is no. It's a funny one. It's a funny one, but yeah. But basically, the georeferencing plugin exposes you some method or function to convert any location to any other location, and it's accessible from a Blueprint or C++ perspective. So currently, I would say no. There is no way to curve a flat mesh using it. There is no magic function that does that, but it could be possible to write a C++ plugin that loads a mesh and iterate over all vertices, getting their x, y, z coordinates, and curve them to the CEF coordinate, something like that, apply some rebasing, and create another mesh for you. So you could use this function to, of course, curve it correctly, but it's not available out of the box.
Next question comes from Alexander Krantz. Is it supporting CDB OGC?
So it's a good question. We talked about the three main databases formats that are supported by the OGC, and we didn't demonstrate in that specific demo for lack of time all the plugins that exist for Unreal. There is a plugin for the OGC CDB that has been created by our friends at Simblocks. So if you dive in, we'll send you the link as well. So simblocks.io is the website, and they released in December last year this CDB OGC plugin for Unreal Engine. It is available through them directly, and you can you can use your CDB formats directly in the context of Unreal using that plugin.
Yeah, I dropped it in the chat.
Thank you. So it's called the CDB SDK for Unreal, and it's coming to us from Simblocks.io.
Making sure I'm gathering these for the forum announcement post as well to make sure that they're exist somewhere a little bit more permanent than the live stream chat. I've seen a couple of questions in regards to Python. Python seems to be a language that is commonly used in simulation applications, and I just wanted to reiterate, we talked about this before, but there are currently no plans to build runtime support for Python. Python is exclusively used as an tool to help you import and do all kinds of automated processes when you're working with the editor, and not as a language that you would use to write runtime logic.
Yeah, but if you are looking for examples that mix a runtime Unreal application along with Python scripting, you can have a look at what the people from Carla did, carla.org. It's an open source driving simulator for autonomous vehicle and sensor simulation. And they are able to make a bridge between some Python scripts and Unreal at runtime. You create your scenario for autonomous driving in Python, and you have Unreal running it currently in real time. Sorry.
We received some more questions while we were asking them here. Some of them are general Unreal Engine questions. Let's see, quick glance through. Leandro Oliveira asked, will Cesium be able to gather 3D models from places with little OpenStreetMap data, like countryside of third world countries?
So that's where your photogrammetric pipeline becomes handy, and that's why having tools which are able to launch a drone in a region, get a photogrammetric survey of an area, and generating that area into the format of 3D tiles allows you to combine that data set with a data set already available by Cesium, right? So you don't rely on Cesium for the content. You have the global content from them on the Ion format, on the Ion server, but you can augment it with your own data set. So launching drone surveys on a region or LiDAR surveys on a region and generating your photogrammetric data set, something that's now accessible for a lot of operators in the simulation environment. And that's one of the great things of having an open format, is that you can feed it with the data set that you want.
And if you have as a side project, you want to make something that gets your OpenStreetMap buildings footprints and generate geotype generic building with nice facade and nice looking building, and export it as a 3D tile format, because you can do it. It's public format. You will be able to generate a new kind of 3D tile layer that we could load in the engine and have your actual buildings.
All right. With that said, I think we're done for questions today. Sebastian and Alban, if there's anything else you would like to cover, feel free to jump into the forum announcement post. I will make sure that you receive all the questions that we received in chat here today. Before I have you leave, I do want to mention that if you've been watching the stream today and you're curious about the use of Unreal Engine in simulation and applications, or for game development, virtual production, media and entertainment, any of those, make sure you visit unrealengine.com, where you can download the engine for free right now and start learning. We do have a library of, I think it's over 160 different videos now when it comes to learning Unreal Engine at learn.unrealengine.com. And you can also find many thousands of tutorials and videos created by our awesome community on YouTube. Make sure you visit. There's a Reddit thread, reddit.com/ourUnrealEngine. We also have Unreal Slackers, which is a unofficial Discord community boasting over 50,000 members, unrealslackers.org. But also make sure to visit our forums, as well as our Twitter, LinkedIn, and Facebook handles, where we post all of the news related to Unreal Engine. It's a lot of good blog posts and project spotlights going up as well, if you're just curious what's going on in the industry with the use of Unreal Engine. If you are a little bit confused by some of the terminology that we've been talking about today in the stream, within about 7 days after the stream, we upload the full transcript to YouTube. And this is a manual transcript that is reviewed by Captioneer. It's the new term I've started calling them. And if there were any terms that you were unfamiliar with and you weren't really sure how to spell them and search for them, the transcript will be uploaded as well. You can just turn on captions when you're watching this on YouTube. What's really nice is that all the timestamps are listed in that PDF that gets uploaded. And so if you're curious about something in particular, you can Control F, search for that, find out when we talked about it, and then go ahead and do any follow-up searches that you might want to do. Please make sure that you fill out a survey. Oh, almost had an instant cough right there. Make sure you fill out the survey. I think we're going to go ahead and drop it in chat right now. Let us know what topics you would like to see in the future, as well how we did today. If there was anything that was missing, make sure you let us know so that we can improve in the future. Also, there are no physical meetups going on right now in the world due to the pandemic, but our communities around the world are still spinning up virtual meetups. You can go ahead and find out where all of those groups are located if you go to communities.unrealengine.com. If you are interested in forming a meetup group in your area, there's also a button right there that says Become a Leader. You can go ahead and fill out that form, and we will go ahead and get in touch with you. Make sure that you submit us all of the amazing projects that you're working on. Good place for that is the forums. Unreal Slackers is another one. We frequently browse Twitter, Facebook, and LinkedIn as well. And you might be one of the community spotlights that we aired at the beginning of the stream. You also get a nice little spotlight in the launcher for a week. We're still looking for new countdown videos. I mentioned this to Seb and Alban as we got started when we were playing the countdown video, that it would be great to receive some countdown videos that are in other areas of the use of the engine, such as simulation and training. These are 30-minute development videos. Speed them up to 5 minutes and send that separately to us with your logo, as well as the name and any links to your studio. And we might go ahead and composite a new countdown video with your content. Make sure that you follow us on social media. And if you do stream on Twitch, use the Unreal Engine and the game development tag. Maybe not if you're doing simulation and training. I'm actually not sure if there's a tag for that on Twitch just yet. We might go ahead and see one in the future as the industry grows. But it's always fun for us to go ahead and look at all the cool projects that you're working on. And Twitch is a good platform for that, where you're also able to interact with the community in real time. Make sure you hit the notification bell on YouTube if you want to see when we go live, as well as all of the content that we're producing. I know the Evangelism team are producing a whole lot of feature videos now that we're unable to visit conferences and do them live. And so expect them on YouTube. There's a lot of cool stuff in the works right now that you'll be able to see in the next couple of months. Next week, I have Richard Cowgill coming back on the stream to talk about how to use NVIDIA DLSS plugin in Unreal Engine. It is now available to be used. You can find it on the marketplace and download it. Get ready, maybe prepare some questions for him. If you watched the last stream he did, I think we spent almost 2.5 hours talking about it. He was showing off some awesome new technologies from NVIDIA, but this time we're actually going to go through exactly how to use the NVIDIA DLSS plugin. And with that said, I would like to thank Seb and Alban so much for coming on today, talking to our audience about simulation and training. There's been a lot of good questions, a lot of good content, and March 30th, right? That's what everyone should look out for.
Yeah, no, absolutely. Thank you very much for having us, Victor. It was really, really interesting for us to be with you, and all of our audience today. If you're building simulation applications and if you don't know where to start, that's super scary. I mean, Unreal is a monster, right? It's huge. You've seen the charts that we displayed here today. If you don't know where to start, it's always easy to send an email, contact us. There's a simulation at epicgames.com that you can use in the simulation context, right? If you don't know how to set something up for either training or analysis, for machine learning, or for any applications you're working on in the simulation domain, just one line, simulation at Epic Games. That will be allowing you to get in touch with the team, and we'll take it from there. So thank you again, Victor, for setting this up, and everybody for attending. It was a pleasure.
Yeah, thank you everybody for attending and for your interesting question.
Just wanted to make sure that Alban did produce 2 videos that we are now hosting on our YouTube channel as well, in the use of the 2 separate plugins. And so if you're interested in a particular segment that is a little bit, I should say, faster and with less of our communication in between, I'll go ahead and link those in chat right now. And you can also find them on the forum announcement post page. Alban was nice enough to put those videos together for us right before the stream. With that said, thanks everyone for hanging out today. Hope you had a good time. So did we. With that said, stay safe, and we will see you again next week. Bye, everyone.